Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 3 for this week. And I just wanted to share something with you. I was made aware of something that I did not know about before, and that you can use your iPhone as a webcam in association with what I'm doing here. And I don't know if you've noticed or not, but I was using the camera that basically comes along with the Mac. And you might notice that, the edges of my clothes or my shirts were a little bit fuzzy and so forth. Well, this is a big improvement. I mean, you can't do much with a face, but at least everything else is better. And so I am now for the first time using my iPhone as a webcam for these recordings, and I like the quality of it quite a bit better. So I just thought I'd share that with you. So let's go on ahead and delve into our topic for today. And, I got to put myself in the corner. I always forget to do that. There we go. So we're going to talk about something called teleconnections today. And basically, these are quick and dirty ways to assess what the upper level flow pattern is doing. I have always viewed them purely as a diagnostic tool and not a prognostic tool. When I hear people say, oh, the Arctic Oscillation caused the cold and snowy winter. No, it didn't. The Arctic Oscillation is simply a quick and dirty number that tells you what the upper level flow pattern is doing. And you can assess that by looking at any weather map at any level. So if you see these values, either negative or positive, and you know anything about what they're actually trying to calculate, then you can say, oh, I can pretty much tell what the upper air pattern would be if that index is a certain value. So that's really all there is to this. So I'm going to take a look at 3 of these today. And typically, these 3 have a pretty strong correlation, not foolproof, but a pretty strong correlation with how the winter turns out across much of North America. So the first one is the Arctic Oscillation. The acronym for it, you knew there had to be one, right, is AO. And basically, you're taking a look at pressure patterns here around 1,000 millibars. Now, in the negative phase, if the pressures are much higher up here in the Arctic and down into Canada and maybe extending a little bit down here into the central part of the United States, and the pressures are lower than normal along the East Coast and also back in the West, then that is a negative phase, okay? And that tends to be associated with colder than normal weather in the east. If you can imagine like a big area of high pressure here, the clockwise flow around that is going to bring cold air down into the eastern part of the United States. So if you want colder than normal temperatures in the winter, you're looking for the AO to be negative. Now, if it's positive, then we've got lower than normal pressures up in the North Pole and down into the Arctic and Canada, and above normal pressures across much of the United States, which means basically that all the cold air is bottled up here and has a hard time penetrating down into the United States. So again, if you're looking for colder than normal temperatures, you would look for a negative AO. Okay, then we go to our second index here. Oh, and by the way, I just forgot to add this in here. We're basically taking a look at how the pressures compare to normal all the way from 20 degrees north latitude up to the North Pole. And again, that's what these colors basically represent. All right, so the Pacific North American pattern, or the PNA, is taking a look at 500 millibar height anomalies in 4 different locations and how they compare to each other: near Hawaii, the Aleutian Islands, the Rocky Mountains, and the southeastern United States. In the positive phase, the 500 millibar heights are above normal in western North America and below normal in the east. So you can sort of imagine the jet stream going up like this and then diving into the southeast. And so that would also favor below normal temperatures and above normal precipitation, and if it's cold enough, snow. So for a cold and snowy pattern, you want a positive PNA and not a negative one, where you've got a trough in the west and a big ridge in the east, okay? So far, you want negative AO and a positive PNA, okay? Now, let's move on ahead to the North Atlantic Oscillation. And here, we are taking a look at pressure differences between Iceland and the Azores, okay? So if the pressures are much greater in the Azores than they are in Iceland, then that tends to promote a positive mode here, where basically you have cold and more sea ice up here in the Arctic, but it stays relatively warm across the United States. The United States is this area right in here. But if the pressures are unusually high in Iceland compared to the Azores, then we get this big blocking ridge up here over Greenland, which tends to keep the trough in the eastern United States. You notice it has cold and snowy here over the mid-Atlantic states. Must be somebody like me, wishful thinking. So the NAO you want to be negative if you want wintry weather, or at least colder than normal temperatures, and a positive NAO would promote exactly the opposite. So negative AO, positive PNA, and negative NAO, okay? So I went through a very tedious process this afternoon, and I took a look at the top 10 coldest Decembers, okay, at RDU, and then compared all of these three index values and what they were in those specific years. Now, you may remember December of '89. It was the coldest December on record. It was the year that they had the big snowstorm along the North Carolina coast and back into the coastal plain. It was the year that the television towers fell and Jim Goodman, the owner of Capital Broadcasting, pulled off a miracle by basically, I believe, going to a station in Fayetteville and, in a sense, borrowing their transmission tower for the next several months while ours was rebuilt. And so that was a very, very noteworthy December. But anyway, if you take a look at these values here, remember, we want negative AO, positive PNA, and negative NAO. And I've shaded in blue all the times that those values were consistent with a cold winter, and the reds where it wasn't consistent. So you can see that all of the AO values are negative, the average minus 1.5. The PNA was negative every time, or positive every time, with two notable exceptions, 2010 and 1955, but it didn't stand in the way of December being cold. And then the NAO was negative except in two instances here, 60 and 55, and they were so close to zero that you could probably call that neutral, okay? Now, we take a look at the top 10 coldest Januaries on record, and of course 1977 is the coldest month on record by far at RDU. There's no month, any month of the year that's even close to that. And you can see that everything was consistent there, heavily minus AO, heavily positive PNA, and heavily negative NAO. The only exceptions on the AO were 1988 and 1984, for the PNA 1982, and for the NAO there were four exceptions, 81, 88, 78, and 84. When you average them all out, then they came out to be negative, positive, negative, but there were some notable exceptions there. Now we move on to the top 10 coldest Februaries, and in the case of the AO, two notable exceptions, 2015 and 1967, but the rest of them are all negative. The PNA only one time was it out of whack, and that was 1979, and the NAO again had four exceptions, 2015, 1980, although 80 and 67 were pretty neutral, and 1970. But again, when you average them all out, it's minus, plus, minus. And then finally, on to March. And for those of you old-timers that were around North Carolina in 1960, you remember that was the year that it snowed every Wednesday? It was an incredibly cold and snowy March. And so if we highlight these values here, the AO was negative every single time except 2014 when it was plus 1.2, but the average was minus. The PNA did not correlate well at all, okay? In fact, the average was actually below zero, so the PNA had no way correlated to the cold Marches, and the NAO, strong correlation every year but just the winter of 2014. March of 2014 had a negative value. So again, on average, negative, positive, negative correlates to a cold winter in North Carolina, or at least in the central part of North Carolina. But there are some exceptions. Nothing is foolproof in the meteorological world, okay? And again, I see this as simply a quick and dirty way to assess what the upper level flow is doing, okay? This doesn't cause the upper air flow to be a certain way. It is indicative of what the upper level flow is, and it's simply a quick and dirty way of assessing that. All right, so if you hear those terms thrown around, hopefully that makes a little bit more sense as to what they mean. That is bonus weather video number 3 for this week. Hope you have a wonderful Friday evening and an even better weekend, and we will talk to you again on Monday. Take care, everybody.